Alright, so welcome to week 5, and today we're going to be diving into one of the most powerful transformative technologies in AI: transformers and attention mechanisms. These concepts are the foundation of modern language models like ChatGPT and significantly change how machines understand and generate language. By the end of this presentation, you will have a deeper understanding of how transformers work and self attention means and why mechanisms are so powerful. Now, last week we went over transformers and a bit of attention mechanisms, but let's go into a little more depth into this topic. So, let's take a little recap from last week. Transformers. Transformers were introduced in 2017 in the groundbreaking research paper Attention is All You Need. This model replaced older techniques like recurrent neural networks such as RRNs and CNNs, which had limitation when processing long sequences of text. Transformers use mechanisms called self-attention, allowing them to analyze all words and sentences simultaneously rather than sequentially. This makes them more efficient and effective in natural language processing tasks. Next, tokenization and embeddings. The first step is processing text with transformers in tokenizations. This process breaks down text into smaller units called tokens, which could be entire words, subwords, or even individual characters. Each token is then mapped to a numerical representation called an embedding. These embeddings exist in high dimensional space where words with similar meanings are positioned closer together. This means the model to understand the relations between the words and use them efficiently and in different contexts. The example would be if king is man, then if instead of a king and man and you replace man with woman, it would be changed from king to queen. Next, the role of attention. One of the key features of transformers is the attention mechanism, which enables models to understand the relations between words based on context. For example, the word mole has multiple meanings. It can refer to an animal or a unit of measurement or even a spy. The attention mechanism helps the model determine which meaning is the more relevant in a given sentence by analyzing surrounding words. Next, we have multi-headed self-attention. To further improve the model's ability to capture context, transformers use multi-headed attention. Instead of using a single attention mechanism, transformers use multiple attention heads, each analyzing a different aspect of the sentence. One head may focus on grammar, another on meaning, and another on the relationship between entities. This parallel approach ensures that different linguistic features are captured efficiently and making the model more robust in understanding generating text. Next, we'll be going into the query key value system. Now, the self-attention is driven by query, key, and value, or QKV system. Each word in a sentence generates 3 vectors. The query represents the word is searching for in the sentence. The key represents potential matches for the query, and the V, the value, holds the information that should be transferred if a match is found. The transformer calculates how much attention should be given to each word in relationship to another, helping it determine meaning and context. Next, we'll be going into softmax and attention scores. The self-attention mechanism relies on mathematical operation called the dot product to measure the similarity between queries and keys. However, these raw values can range widely, making them difficult to interpret. To solve this, transformers use softmax function, which converts the values into probabilities between 0 and 1. Higher probabilities indicate stronger relevance, ensuring the model prioritizes the most important words in a sentence. Next, we'll be going over layering and transformers. Transformers consist of multiple layers, each refining the understanding of the text. Each layer has three components. 1. Multi-headed attention. Processes relationship between words. Second is feed-forward networks. Apply additional transformations into data. And third, normalization layers, ensuring stable training by standardizing inputs. By stacking multiple layers, transformers progressively refine their predictions, improving accurate and context understanding at each step. Next is training large language models. Transformers are trained using objective called next word prediction. The model processes a sentence and attempts to predict the most likely next word. If the prediction is incorrect, the model adjusts its internal parameters through a process called backpropagation. This involves updating millions or even billions of numerical weights using massive datasets and powerful GPUs. The more training data a model sees, the better it becomes at generating natural sounding text. And finally, the conclusion and the future prospects. Transformers have revolutionized language or natural learning language processing, enabling AI to understand and generate human-like text with unprecedented accuracy. The attention mechanism plays a crucial role in making AI models context-aware and significantly improving their performance in tasks like translation, summarization, and text generation. Looking ahead, AI models will continue to evolve, becoming more efficient, capable of reasoning, and handling even larger text contexts. This innovation opens new possibilities for AI applications in education, healthcare, and beyond.